In this video, we're going to discuss solving quadratic equations by completing the square. The method of completing the square is best done when your equation is in the form y is equal to ax squared plus bx plus c. Your a value needs to be equal to 1. Your b value, it's easiest if the b value is even. If the b value is odd, you can still use the method of completing the square. It's just going to be more difficult. But if your a value is not 1 and you can't make it 1 by dividing the whole equation by some number, you cannot use the method of completing the square. Let's look at an example. Y is equal to x squared plus 6x minus 2. Whenever we're solving a quadratic equation, what we're really solving for are the roots or the x-intercepts of that graph. Whenever we're solving for the x-intercept of any equation, of any graph, we want to set y equal to 0. 0 is equal to x squared plus 6x minus 2. When we're using completing the square, we want to have our constant on one side and all the x's, x squared, everything that's attached to the x's on the other side. So we're going to add 2 to both sides of the equation. Now we have 2 is equal to x squared plus 6x. To do completing the square, we need to find some value for the side of the equation with the x's, which in this case is the right-hand side. We need to find some value, some constant, that we can either add or subtract from this equation that will make the right side of the equation a perfect square trinomial. A perfect square trinomial is, let's say, x minus 2 times x minus 2. Or x plus 4 times x plus 4. When we FOIL these out, we're going to get some trinomial. A perfect square trinomial means it's comprised of 2 of the same factors, like x minus 2 times x minus 2, x plus 4 times x plus 4. To find some value of c that will make x squared plus 6x plus some constant, a perfect square trinomial, we're going to take 1/2 of b and square that. So 1/2 of b is 1/2 of 6, because b is always the coefficient of the x term. So 1/2 of 6 is 3, and then we want to square that value. 3 squared is 9. So we're going to add 9 onto this side of the equation. We can't just add 9 to one side of the equation. If we're adding 9 to one side of the equation, we also have to add 9 to the other side of the equation. So 2 plus 9 is 11 is equal to x squared plus 6x plus 9. Now we want to factor this side of the right side of the equation. We want to find factors of 9 that add up to 6. Factors of 9 are 1 and 9, and 3 and 3. The factors that add up to 6 are 3 and 3. And we assumed that we would get 2 of the same thing. Why is that? Because we want to rewrite our equation as the product of 2 of the same factor. We rewrote our equation to be a perfect square trinomial so that we would have one factor times itself, or 2 factors, the same factor. Since we have x plus 3 times x plus 3, we could rewrite this as x plus 3 squared. We just rewrote x plus 3 times x plus 3 as x plus 3 squared. It means the same thing. Now we want to get x alone. To do that, we're going to take the square root of this side and the square root of 11. But remember, whenever you're taking the square root of a number, it's plus or minus. Why? Because let's say you have the square root of 4. The square root of 4 is 2 or negative 2, because 2 times 2 is 4, and negative 2 times negative 2 is also 4. So let's go back to our question. Plus or minus the square root of 11 is equal to the square root of x plus 3 squared. Whenever you're taking the square root of something being squared, the square root symbol and the squared cancel each other out, and we're just left with plus or minus the square root of 11 is equal to whatever was inside, which is x plus 3. Now we need to get x alone. To do that, we're going to subtract 3 and subtract 3. Plus or minus the square root of 11 minus 3 is equal to x. And these are our 2 values of x. One value of x is equal to positive the square root of 11 minus 3. The other value for x is equal to negative the square root of 11 minus 3. So where this graph would cross the x-axis would be at these two coordinates. We could find approximately where that would be on the calculator. Let's do the square root of 11 minus 3, and then negative the square root of 11 minus 3. So this graph would cross at approximately x is equal to negative 6 and x is equal to 0.3. Let's look at another example. Y is equal to x squared minus 4x minus 5. We want to solve for the roots of this quadratic. To do that, we're going to set y equal to 0. So 0 is equal to x squared minus 4x minus 5. Whenever we want to solve an equation using completing the square, the first thing we want to check is a equal to 1. In this case, x squared or 1x squared is the same thing. The coefficient is 1, so we can use completing the square. Is b, the coefficient of the x, is it an even number? 4 is an even number, so we are going to use completing the square. When we use completing the square, we want the constant on one side and the x squared and the x and the coefficients on the other side. So we're going to add 5 to both sides to bring 5 to the other side. 0 plus 5 is 5. 5 is equal to x squared minus 4x. Now we need to make the right-hand side of the equation, the side of the equation with the x's, into a perfect square trinomial. To do that, we're going to take 1/2 of b and square it. 1/2 of b, 1/2 of negative 4, is negative 2. Then we're going to square negative 2. Negative 2 times negative 2 is positive 4. So we're going to add this value to both sides of the equation. Plus 4 to the right-hand side. Since we're adding 4 to the right-hand side, we also have to add 4 to the left-hand side. So plus 4 to the left-hand side. 5 plus 4 is 9. 9 is equal to x squared minus 4x plus 4. Now we need to factor this right-hand side of the equation. When we wrote the equation, we wrote it in such a way that we would be able to get two of the same factors multiplied by each other. So two of the same number that multiply by each other to give us 4 are either positive 2 and positive 2 or negative 2 and negative 2. Since our b term in this case is negative 4, we need our factors to add up to b. So we are going to use negative 2 and negative 2 because negative 2 plus negative 2 is negative 4. So 9 is equal to x minus 2 times x minus 2. Since we have two of the same factors, we can rewrite that as x minus 2 squared, because x minus 2 times x minus 2 is the same thing as x minus 2 squared. Now we're going to take the square root of both sides of the equation to isolate the x. Whenever we're taking the square root of a number, we have to do plus or minus that number. When we're taking the square root of something inside, it's something being squared, the square root symbol and the squared cancel each other out. So we're left with the plus or minus the square root of 9 is plus or minus 3 is equal to x minus 2. And then to get x totally alone, we're going to add 2 and add 2. So x is equal to plus or minus 3 plus 2. So let's see what x is equal to. X is equal to positive 3 plus 2, and x is also equal to negative 3 plus 2. Positive 3 plus 2 is positive 5. Negative 3 plus 2 is negative 1. That means that the roots of this equation, this graph would cross the x-axis at x is equal to negative 1 and at x is equal to 5. Let's look at one more example. Y is equal to 4x squared plus 8x minus 12. Whenever we're solving for the roots of a quadratic equation, we always want to set y equal to 0. So 0 is equal to 4x squared plus 8x minus 12. We want to solve this using completing the square. Whenever we're solving any equation using completing the square, our a value has to be equal to 1, and it's nice if b is even, it doesn't need to be even. But in this case, is a equal to 1? It is not. A is equal to 4. A is always a coefficient of the x squared, so a in this case is 4. Is there some way we could rewrite this equation where a would be equal to 1? Let's see. If we divide this term by 4, since we're dividing that term by 4, we have to divide all the terms by 4 on both sides of the equation. 0 divided by 4 is just still 0, so that didn't change anything. 4x squared divided by 4 is just x squared because the 4's cancel out. 8x divided by 4 is 2x. And negative 12 divided by 4 is negative 3. Now we have a value of a that's equal to 1. Good. Is b even? Yes, it is. B is equal to 2, so we can use completing the square. Let's do it. Whenever we're using the completing the square, we want the constants on one side and the x squared and the x term on the other side. 0 plus 3 is positive 3. 3 is equal to x squared plus 2x. We need to find some way to rewrite the right-hand side of the equation, the side of the equation with the x and the x squared. We need to rewrite that as a perfect square trinomial. A trinomial that will have two of the same factors. To do that, we're going to take 1/2 of b, which in this case is 2. We're going to take 1/2 of b, which is 1, and square that value. 1 squared is just 1. We're going to add that value to the right-hand side of the equation. And since we're adding it to the right-hand side of the equation, we also have to add it to the left-hand side. 3 plus 1 is 4. 4 is equal to x squared plus 2x plus 1. Now we want to factor the right-hand side. We need to find factors of positive 1 that add up to 2. Factors of positive 1 are just positive 1 and positive 1, or negative 1 and negative 1. Factors that add up to positive 2 are positive 1 and positive 1. So 4 is equal to x plus 1 times x plus 1. We can rewrite x plus 1 times x plus 1 as x plus 1 squared. So x plus 1 squared is equal to 4. Now we're going to take the square root of both sides of the equation to get x alone. Whenever we're taking the square root of a number, we do plus or minus that number. The square root of something being squared cancel each other out. So we're left with x plus 1 is equal to plus or minus the square root of 4, which is 2. We want to get x alone, so we're going to subtract 1 and subtract 1. X is equal to plus or minus 2 minus 1. This means that x is equal to positive 2 minus 1, and x is also equal to negative 2 minus 1. Positive 2 minus 1 is positive 1. Negative 2 minus 1 is negative 3. That means that this parabola would cross the x-axis at x is equal to positive 1 and at x is equal to negative 3.